So in this question we've been given the following two equations and we've been asked to find when, for what values of m does the equations have an infinite number of solutions and when does it have no solutions. So to solve this, the first thing we're going to do is we're going to set up the matrix equation of AX equals B, where the matrix A is going to be simply the coefficients, which is 3m, m plus 2 and 5. X is obviously our pronumerals, x and y, and B is our solutions, 5 and m. Now, we know that there are no unique solutions whenever the determinant of A is 0. In other words, when the inverse of A does not exist. So what we do is we find the values of m that will set the determinant here equal to 0. Now the determinant, of course, of A is equal to AD minus BC, which is going to be 3 times 5 minus m times m plus 2, which is 15 minus m squared minus 2m. Now, in order to solve this, all we need to do is simply say, well, we have minus m squared minus 2m plus 15 equals 0, or if we write it by rearrangement, we can write it as m squared plus 2m minus 15 equals 0. And we need to simply find for what values of m is that true. So, to solve this quadratic, what we do is we use the quadratic formula. So we know that m is equal to minus 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 15 all over 2 times 1, which gives us negative 2 plus or minus the square root of 4 plus 60, which is 64, divided by 2, which gives us negative 2 plus or minus 8 over 2, or negative 1 plus or minus 4. So the two values we're going to get are that m is equal to negative 5 or m equals positive 3. Now what we need to do is need to see, well, what do these values mean? Well, if we write out the equations using the solution m equals negative 5, so we'll start with that one. M equals negative 5 would give us 3x minus 5y equals 5, and negative 5 plus 2 is negative 3, plus 5y equals negative 5. Now clearly these two equations are the same, except that one is the negative of the other. So therefore, this is where we have infinite solutions. And if we take the other equation, m equals 3, another situation, then when m equals 3, we have that 3x plus 3y equals 5, and we'll have 5x plus 5y equals 3. Now, if we divide both equations by the coefficients, that's basically going to give us that this equation is the same as x plus y equals 5 over 3, and this equation will be that x plus y equals 3 over 5. Clearly these two equations are incongruent, in other words they don't give the same solution. So this is the case where we have no solutions.